So your MCS2, spring 2019. Okay, good. Okay. First of all, before applying the function sum recursive, the argument will be evaluated, and supplied argument is code function call. That code will be removed. So actual argument will be the list 1, 3, 4, 5. Okay, the list will be passed to the argument present in the argument list. Okay, so the value of x for this sum recursive call is this list of 4 numbers. Okay, and the whole definition will be executed with the value of x, this one. Okay, control of execution after matching the header function call with the header line of the function definition. Control of execution will go to the body of the function definition. Okay, and in the body we have only one const statement. Whatever const statement we return, sum recursive will return that value. Okay, and in the const statement we know that it is a condition statement. There are 2 clauses. First is the default class, first is the base class, and second is the default class. Okay, control of execution will go in sequence, starting from the first class. It will check x is an empty list, null x, value of x. Before applying that null, x will be valued to its value, and then you will list of 4 numbers. It is not an empty list. Null function will return false. So control of execution will go to the default class, the next class, and in the next class, plus function is being applied. Whatever the plus function value, plus function will return, that value will be returned by the const statement and by the sum recursive function. Okay, whatever the plus operator, the plus function will return, that result will be returned by that function. Now we want to see what are the arguments of that plus function. Plus function is being applied, supplied argument. The first supplied argument is car of x. What is car of x? 1. Before applying the function, argument should be evaluated, and after evaluating car of x, the actual argument is 1. Because the car of x, the first element of x is 1. First element of list x is 1. Now the second argument is sum recursive. It is the function which we want to trace. Otherwise, if it would not have been that function which we want to trace, we could have directly written the output, as in the case of car. We have not written the car and the list x. We have directly written the output, because car is not the function which we want to trace. Okay, so we have directly written the output, the actual argument after evaluation. But sum recursive is the function, the supplied argument of this second supplied argument of this plus function call is that function which we want to trace. Therefore, we want to write that supplied argument, second supplied argument of the plus function. Whatever value will be returned by this sum recursive, that will be the actual second argument of this plus, and plus will add 1 to that value. And for this function call, before applying the function, the argument must be evaluated, and its argument is cutter of x. Okay, cutter is not that function which we want to trace, so we can directly write the output of cutter of x. What will be the cutter of x? Amal, can you tell us? Exactly, very good, excellent. 3, 4, 5. For the cutter, first element will be removed. This is the actual argument of this sum recursive. And sum recursive, control of execution, LISP interpreter will try to find out its definition. Okay, where is the definition of the sum recursive? This is the definition of the sum recursive. So control of execution will match this call with the header line of that function. If we match this call with the header line of that function, what is the value which is being passed to x in this function call? It is the reduced list. Okay, it is the list of 3, 4, 5. So now in this case, value of x is 3, 4, 5. Okay, and with this value, the code of the sum recursive will be executed. And control of execution will go to the body of the code. In the body of the code, we have a const statement, and in the const statement, we have 2 clauses. The first clause, null x will be checked. X is an empty list? No. So first clause is again false. Control will go to default class, and in the default class, we are calling the plus function. Therefore, we want to see what are the actual arguments of the plus function. The first argument is car of x. The first argument is car of x, which is 3. And second argument is recursive call of sum recursive on cutter of x. If we take cutter of x, then the 3 will be removed, 4, 5 will be returned in the original list. So now again, this plus is waiting for its second actual argument. First actual argument is 3, which has been produced by the car function. The second actual argument will be produced by this function. Okay. Whatever value will be returned by this, plus will add 3 to that value. Now, controller execution, LISP interpreter, computer will again try to find out its definition. Where is the definition? The same as the definition. Controller will go to the beginning of the definition. It will match the header line with this function call. The value of x will be 4, 5 within LISP. Now 4, 5 within LISP will be passed to the x as its value. And again controller go to the body of the function. We have null x. X is an empty list? No. Again, first class is false. Controller go to the default class. Plus star of x 4 and some recursive on cutter of x 5 within list. Okay, good. Now again, in this recursive call, value of x is a reduced list, 5 within list. Okay. And now again, the default class will be executed. Star of x 5 and some recursive on cutter of x empty list, nil. It is nil. Okay. When this value will be passed to the function as value of x empty list, null function will return 0. True. Null function will return true. Okay. And controller execution will return that value from the first class in the count statement. Controller now not go to the second class, not go to the default class because the condition is true. Controller will execute that part and that value will be returned. Okay. So in this case, this sum recursive has produced the second actual argument of this plus, which is 0. Which is 0. Now plus will be applied. 5 plus 0, it will add both these numbers and this plus will return 5 in the second default class of this sum recursive call. Okay, so it will return 5 and then this plus was waiting for its second actual argument. Now it can be applied, it can be executed. 4 plus 5, 9 and 9 plus 3, 12. And 12 plus 1, 13. This plus was waiting in the default class of the outermost call. Okay. And it will return 13 and whatever it will return, that will be returned by the count statement and that will be the return value of our top level sum recursive call. So you can see the answer is 13. I hope it is understandable. Okay, you may note it down quickly so that we may move to the next example.